All right, I wanted to do a video for you. So if you're in my Tuesday class, then you have a quiz on factoring. And if you're in my Wednesday class, your test on factoring is coming up. So here's just a few questions I thought we would go through. Okay, so let's look at all the different types of factoring. So let's say we're trying to factor x squared minus 5x minus 24. As we're doing these problems, I want you to keep in mind that three-step factoring plan. You're going to think about and pull out a common factor if there is one. You're going to factor what's left depending upon whether it has 2, 3, or 4 terms. You're then going to factor again. Okay, so that's your plan on all of them, and that's if possible. So if you're faced with a problem like x squared minus 5x minus 24, first, you notice there's nothing common to all 3 terms. So that means since it's 3 terms, you're going to try unfoiling. Whatever goes into the first spot has to make the x squared. So you know that's an x times x. And then the numbers that go in the last spot have to multiply to be 24. So that's when you need the list of all pairs of factors of 24. Like 1 and 24 or 2 and 12. And sometimes this is where the problem comes in because you miss one of the possible pairs. So just be systematic. 1 divides into 24 times. 2 goes in there 12 times. 3 goes in there 8 times. 4 goes in there 6 times. 5 doesn't go in there, and then we're back at 6. So there's a complete list of pairs of factors of 24. Now, this particular problem should be a fast one for you as far as getting the numbers, because the coefficient of the x squared term, that's called the a value. A is equal to 1. So that means there's nothing coming from in front of the x that's going to contribute to that middle term. So you should try the 3 and the 8 because you can get a 5 out of that. And then you should think about how this foils and how the inside 2 and the outside 2 are what get combined to make -5. And so then you have to think about putting positives or negatives on these so that you'll get a -5. You want this to be -5x. So the bigger one would have to be negative. Smaller one would have to be positive. And then you double check that that gives you the sign that you need at the end. And then you've checked everything. And you know that if you FOILed back out x plus 3 times x minus 8, that would be equal to what we started with. Okay? All right, let me try another one, but this time let's make the a value not equal to 1. So something other than 1. That makes it a little bit harder. So for this one, I want to do 12x squared plus 8x minus 15. This one's a lot harder than most that we do, but I just wanted to be fair and not just do easy problems during our examples. First off, nothing goes into all 3 numbers evenly. 2 would go into both 12 and 8, but not into the 15. Okay, 3 would go into the 15, but not in the others. Basically, nothing's going to go into all of them. That means I'm going to unfoil. Okay. Now, here's the problem. When I think about the factors of 12, I have 1 and 12, 2 and 6, 3 and 4. And that gets all of the factors of 12, but that's a lot of possibilities. And 15 is 1 and 15 and also 3 and 5. So I have a lot of possibilities there. So this problem could take a while to factor. Okay. Now I am looking at how the middle term is relatively small compared to what I see at the beginning and the end. My habit is to go ahead and use the pairs that are closest together. So I might put a 3x in the first one and a 4x in the second one. And then I want you to really think about what I keep bringing up. If I'm going to try 3 and 5, when I do, I am not going to put the 3 there, because then there would be a common factor, but we just said there wasn't a common factor. So if I'm going to try the 3 and the 5, I'm going to put the 5 there and the 3 at the end. All right, so let me see if that's going to work. So now I'm checking to see if it's a good candidate. So 5 times 4x, that's 20x. This is 9x. And remember, what I'm doing here is really just based on what would happen if I were to FOIL out what I put. It has to wind up equaling the 12x squared plus 8x minus 15. So I know the middle term comes from when I multiply the inside 2 and when I multiply the outside 2. So I'm just testing that. When I see the 20 and the 9, 20 plus 9 is 29. 20 minus 9 is 11. Neither one of those, that means no matter what I do, I can't get an 8. And switching the 3 and the 5, remember, wouldn't work because a 3 can't go in that first spot. Now, that doesn't mean that 3 and 5 are wrong, but it means that if 3 and 4 are in the first spots, then 5 and 3 won't work. So now, before I abandon the 3 and the 4, I'm going to check the 1 and the 15. I don't feel good about this. And probably pretty quick, we'll find out I'm wrong. I wouldn't try the 15 there because then 3 and 15 would have something in common. So if it's going to work, 15 would have to be at the end. Okay, wait a minute. That's 4x. That's 45. There's no way I could get an 8 out of that. So what that tells me is 3 and 4 is not going to work because I've tried it with both 3 and 5 and 1 and 15. Okay, so you got to know the process and know that when that happens, it just happens sometimes. And don't let it get to you. So we're going to go back maybe and try the 2x and the 6x. So we'll start over again. We'll try the 3 and the 5. Okay. This is just part of the process. You have to know the process and be confident about that. And then you just work at it until you get it to work. Most of them don't take this long, but I purposefully built one that might take a little bit longer. All right, now I kind of like what I'm seeing here. I put the 3 and the 5 in, and then I checked. I got an 18x and a 10x. And I can see there is a way to make that be an 8x, but I would need this to be negative. So I'll put a minus here and a plus there, and I'll get what I need in the middle. I'll get that 8x, and a positive and a negative would give me the negative 15. So there it is. Okay, that would be the answer to number 2. Okay, so the first 2 problems I did was just kind of a review of 2 of the types of factoring. When you have trinomials, sometimes what's in front of the x term will be an understood 1. Sometimes what's in front of the squared term, I said the wrong thing, let me go back. Sometimes what's in front of the x squared term is a 1. The numerical coefficient is a 1. Sometimes it's something other than 1, and that's when they're a little harder, but you can still get them to work. Just remember to look for a common factor just in case, but there just wasn't one on these, okay? All right, let's try another. All right, so what if you had a problem like this? 81x squared minus 25. First thing you would do is look for a common factor, okay? There's no common factor. Nothing goes into both 81 and 25. This involves squares, so you're going to unfoil. These are perfect squares, so you're going to use a 9x, a 9x, and a 5, and a 5. And then this is the type that by now you should be able to do pretty quick. You know the signs have to be different to give you the negative, and by doing that, that makes the middle term add up to be 0, cancel out. Okay, so your answer would be 9x plus 5, 9x minus 5. Now, what if you had had like a 81x squared plus 25? That one would be prime or not factorable. Okay, that's because you can't make it be a positive in the middle. So if you had 81x squared plus 25, there's nothing you can really do here. This would be the most likely choice, but to make the middle term go away, you need the signs to be different. But to make this to be positive, these would both have to be positive, and then you'd get a middle term. See that? So either they're both positive, so you get a middle term, which you're not supposed to have, or if you make one of them negative, you wind up getting rid of the middle term, but then you get a negative instead of a positive. So there's really no way to resolve that. That's why you say that type is prime or not factorable. Okay. All right, and then let's look at one more here. This is, how about this one? 36x squared plus 60xy plus 25y squared. Okay, first off, this could have a common factor. The numbers are kind of big and you got multiple variables. So you should think about the GCF. But you see how there's x's only in the first two? There's no x's in the last one. And there's no y's in the first one. So there's no variable common to all of them. And then you also don't have a number common. Like 25 is only divisible by 5 or 25. And 5 doesn't go into 36. So this actually doesn't have a common factor that needs to be pulled out. It's 3 terms, so you should unfoil it. You should be thinking the first thing has to come from the first term. And what you're supposed to notice is that 36 and 25 are perfect squares. See, 36 is 6 times 6, and 25 is 5 times 5. They're special. It doesn't mean that 100% for sure it's going to factor that way. But it means that that should be your first try, because a lot of times it does. So a 6x and a 6x, a 5y and a 5y is what we'll try. Okay, and notice the y might bother you, but by putting the y there at the end, that gives you in the middle a 30xy, and here's another 30xy. It gives you the xy you need in the middle. By putting the y there at the end, you also get the y squared, don't you? Okay. All right, so what we want to do here is we want to make both of these positive. And then that's going to give us the 60xy we need in the middle, and everything else works as well. And so 3 and 4, let me back it up a little bit, both involve those special numbers that were perfect squares. Okay, so look for those. Okay. All right, and then I want to do 2 more on this video. And I want to do one that's a perfect, that involves cubes. So here's one that involves cubes. Okay. And then I'll do one that involves 4 terms. Okay. So on question number 5, we have 2 terms. Okay. They have numbers that are kind of big, but 64 is even and 343 isn't. I don't see anything really common, and I still see a cube on this. Okay. So that makes me think I'm going to use a cube formula. Okay. So what you should do is you should maybe leave a space and go down a little bit and write the cube formula. So it's going to break down into 2 terms and then 3. This is going to be a plus b. You don't need to memorize it. You just go read it off the sheet or get it off the board. There's your cube formula. Okay. All right. Then what you're going to do is go back, and this is really important. You're going to think about what really got cubed to make the 64x to the third happen. 64x to the third is not going to go in for the a. And then you got to think about what was cubed to make 343. Okay? So you got to think about that. That's the part that you need to take some time with. So you should be thinking, what times itself 3 times gives me 64? And you can just guess and check your way to it, and you'd find that 4 times 4 times 4 would be that. Okay, so inside here, I would need a 4 together with an x to get a 4x cubed. All right, then here at the end, 343, I don't know that. So I'm just going to keep going. So 5 times 5 times 5, when I check it on my calculator, it's not big enough. 3 6s multiplied together. Then I try 3 7s, and that's when I find out that's 343. So this would be a 7. Okay. All right, now, see what you're going to do now? See, this formula says whatever's in the first spot, that's your A. Whatever got cubed in the second spot, that's your B. So that means A is 4x, B is 7. A is 4x, and it gets squared there. A is 4x, and B is 7. B is 7, and it gets squared, okay? All right, so that's going to be 4x plus 7. This is going to be then worked out. It's going to turn into 16x squared. Don't make the mistake of leaving this 4x squared. A lot of people do. Don't make that mistake. See, this 4 would have to get multiplied by that and get you to 64. So if you left it with a 4 right there, that would be wrong. Then 4x times 7 would be minus 28x. And then 7 squared, that would be 49. Okay. And then this looks factorable, but the formula stopped here because that can't be broken down more. So here would be your final answer. Okay. All right, now one more type of the basic types of factoring I want to look at. Oh, let me back this up a minute. Here's something a little tricky that can sometimes happen. What if I threw like an X on this? Okay, that changes everything because X would be common, and when you factor it out, you'd have 64x squared plus 343, and 343 is not a perfect square, plus this is a plus sign here, so then that's where you would have stopped. So this was a what if there had been an extra x here at the end. Then when I take out the GCF right there, what's left can't be broken down anymore. This one was a cube because it remained, there wasn't an x with the 343, and it still had a cube in it. Okay. All right, now, the last one I want to do in this video has 4 terms. So let's say we had something like 2x to the third plus 3x squared minus 18x minus the 27. All right, so what I would do on that then, since I look at it, there's nothing common to all 4 terms. What I would do would be to factor by grouping, and you can do it the regular way or the box. I'll show both. Okay, so if you're feeling the regular way, you like that, it's making sense to you. Okay, this is factoring by grouping though, right? Because it's 4 terms. Okay. For the regular way, you would pair the first 2, and you would notice there's an x common. Here, let me rewrite the problem here. 2x to the third plus 3x squared minus 18x minus 27. Okay. So you'd pair the first 2. You'd get the biggest thing you can that's common, which is x squared, and then you'd see what's left. 2x times x squared would give me that, and 3 times x squared would give me the second term. Okay, then you'd look at the last 2, and you'd think about what's the biggest thing you can take out of those, but you have a little bit of a hint because you know you want that first term inside here to be a 2x. So you'd need to bring out a 9, and you need to bring out the negative along with it. So that means that negative 9 times the 2x would give you the negative 18x, and then this would need to be plus 3, so that when that gets distributed, you get the negative 27 right there. Okay, so far so good. Now what we talked about is you got to get used to seeing this thing in parentheses as being a chunk that can be factored out. So that 2x plus 3 is this piece that's common to these two terms. So you're going to bring that 2x plus 3 out in front, and you're going to see what's left. Literally, you can see what's left. You can kind of think about those being gone. See how you'd have the x squared minus 9 left. Right? So that's the factoring by grouping step right there. That's the factoring by grouping part, those steps to there. All right, now this one, I put a little something extra on it. I have a squared on that. And so if I have a squared on that, that squared means that you're going to have to break that down, potentially break that down further. So see how this is a perfect square and so is the 9? Then you want to break this down into x, 3, and 3, one with a plus, one with a minus. So this one had that last step of the process, you know, there was no GCF. You factored, and because it was 4 terms, you chose to factor by grouping. And so occasionally don't forget about the factor again piece. Okay? And so then your final answer has to be the part that's completely factored. All right, now those of you that are doing the box would have taken those 4 terms and put them in the box, making sure the 18x had a negative in front of it, and same with the 27. Then your job is to get the GCF right here, because it represents this common side. And so that needs to be x squared. All right, now once you do that, think length times width all the way around the edges. So then this would need to be 2 with an x. So that would wind up multiplying to be 2x to the 3rd. Then that x squared at the top would get multiplied by a 3 to get 3x squared. And then the 2x that we had over here would multiply times not 9, but negative 9 to give me a negative 18x. And then when the negative 9 and the positive 3 multiply, they make negative 27 right here. That's kind of a way of checking. And then if you're using the box method, the answer comes from taking what's on one side, putting it in a set of parentheses, and then taking what's on the other side and putting it in a set. It doesn't matter which of those were first. Okay. All right, now what's going to happen after that is you're going to check, since that's squared, about whether it can break down again. And you're going to think, you know what, it can, just like we noticed before, and you'd break it down further, and you'd wind up with 2x plus 3, and then x plus 3, x minus 3. All right, so I wanted to do those 6. Those are kind of covering the basic types of factoring, and I did a few what-ifs on things. I'm going to do one more what-if on this. Don't forget that sometimes you can have a problem. And so like that first one, for instance, that can be a little more messed up. Like we might have had something like this. Okay. 3 times that is 72. Might have had something like this. So let me just do one more problem. So this just gets, again, at that reminder that you don't start right off trying to unfoil. You should look for a GCF. This one has 3 terms. I'm looking for something common to those 3 terms. Then I'll try to factor, and then I'll factor again. Okay? So when I look at this, what jumps out at me right off the bat is the y to the third. See how it's common all the way through? And then 3 would go into 15, and if you tried dividing it into 72, it would go into the 72 as well. So that means you can take out a 3y to the third out of all of that. Then what would be left would be an x squared. In the middle, I would need a 5, an x, and it would need a minus. 3 goes into 72 24 times. The y to the third is already pulled out, so I'd get to there. So don't forget that you could have a common factor you need to pull out first, and then see what's left is just like question number 1. So we'd go in and we'd do the x and the x. We'd think through all the possible factors of 24 till we put the 3 and the 8 in. It's just our final answer has to include that common factor that we pulled out. Okay? All right, so let me save this, and then I'll do another video on the uses of factoring.